Now the alpha. Do you understand where the alpha comes from? It is the delay angle that we have. Do you understand where the pi plus 3 comes from? Right, here we are. If my alpha is stretching from that point there, but that point there, where is it on this graph? Is it at 0? Is it at pi over 6? No, it is at pi over 3. So if I want to define that point there, then it's either going to be pi over 2, but if I want it to be generic, then I must say it is pi over 3 plus alpha. Pi over 3 plus alpha is going to give me that point there. I'm just, don't look at the phase shift now. We are just looking at this red line voltage. If I want to define that point there where I am switching on, then I must go and look at how far is it from 0. And I know where this point is. That point there is at pi over 3. I don't know what the size of alpha is. I've just put it in here arbitrary, but I've now sketched it there. It's 30 degrees. And so now it does come down to pi over 2. But if alpha is varied, and it's not 30 degrees, it's now, say, 40 degrees. What are you going to do then? Or 45 degrees? How are you going to define where does this voltage start that we're going to use to determine the equation for the current I1? Did I answer you? Does everybody follow that? Why the pi over 3? So that there is the V line max, and then sin omega t plus alpha plus pi over 3 we all agree with. And then if I have z here, here I will have minus phi, do you agree? And that will be divided by z. And that thing there is the arctan of omega L over R. That one there in this case is pi over 6. Remember, your calculator must be on rad. And the answer here came down to 81.07 sin 100 pi t plus 0.1888. Now, if you leave out the 0.07, I won't mark you wrong. The only reason why I put it there is so that guys can see, you know, how close are they to that value. That's all. So if we then substitute this and we substitute that into our equation, our first equation, then we can find the following equation: minus 389 plus 81.07, the sine of 100t plus 0.1888 plus 8 to the power e and this is minus 60t. Okay, 100 pi, thank you. 100 pi t. But we said our current is going to start off at 0. So apply initial conditions to solve for that one. So at t is equal to 0, I1 is equal to 0, and we solve that A is equal to 373.7, 373,7. And then we put this back into that equation, and we have an equation for I1. Now the next cycle takes place, takes over right there. There's a change there. Then we're going to switch over to this line voltage. So we have to start all over again with that same equation. But now it's I2. Oh, before we get there, we must know before we get to the next equation, we must know what is the end value of I1. And since we have an equation now for it, we must find out when does the next cycle start. And since the next cycle is going to start pi over 6 later, what is that in time? Well, there is 0, there is 10 milliseconds. If I take 10 milliseconds and I divide it by 1, 2, 3, 4, 5, 6 periods, then I get 1.667 milliseconds. So that point there is 1.667 milliseconds after we applied that voltage to the motor. So then we can say that I1 end is equal to minus 389 plus 81.07, the sine of 100 pi times 1.667 times 10 to the power minus 3 plus 0.1888 plus 373.7 e to the power minus 60 times 1.667 10 to the power minus 3. And we get a value of 2.231 amp. 2.231 amp. So now we have the end value of I1. The end value of I1 is also the start value of I2. But we first have to get an equation for I2. So we repeat. We start off again. I2 is equal to IDC plus IAC plus A. Do you want it A or do you want it B? What did I do it here? Oh, I said A. A e to the power minus RT over L. That one is still the same. This one is different. So that one we know is minus 389 amps. The IAC is now different. In which way is it different? It has got different limits. There is no alpha. So we will have V line max divided by Z, and then sin omega t. There is no alpha. We have to check where does it start. It starts off at pi over 3 plus pi over 3 and then minus phi. And when we solve this whole thing, we get 81,07, the sin of omega t, and minus 0,335. So substituting everything into that one, we get that I2 is equal to minus 389 plus 81,07 sin omega t minus 0,355 plus 8 to the power e minus 60t. Apply initial conditions. Apply initial conditions. And when we apply the initial conditions, we get that at t is equal to 0, I2 is equal to 2,231. Therefore, we fill into here, we say 2,231 is equal to minus 389 plus 81,07, the sine of 100 pi times 0 minus 0,355 plus 8 to the power e to the power 0, and then we get that a is equal to 417,8. Substitute this back into the equation, and you get that I2 is equal to minus 389 plus 81,07 sin omega t minus 0,355 plus 417,8 e to the power minus 60t. Now, we must find out, is this current positive, 0, or negative at the next trigger point? Now, where is the next trigger point? On the graph, there is the next trigger point. There I am going to switch over to the next phase. Do you agree? Now, how far in time is that? It is 30, 60, 90 degrees further. That's 5 milliseconds. Okay? Because if I have 1, 2, 3, 4, 5, 6 times 30, I get 180. That gives me 10 milliseconds. So half of that will give me 5 milliseconds. So therefore, I go to this equation. I say at 5t is equal to 5 milliseconds, I2 is equal to, and I get a negative number, minus 2,823 amps. What does that mean? Yes. How do I see that's where it switches over? Okay. If I go on this, maybe I can get another color now, yeah. I'm now busy with this phase here. So this phase is going to carry on until that point. That's the longest it can go. After alpha, I'm going to switch over to the next phase here, that one there. So where is the furthest point that I can go on this phase? Sorry, this line voltage. It is there where I am going to switch over to the next line voltage. That one. That one is the one that I want to switch over to, but I can't switch over to it at that point there because the thyristor has not been switched on. The thyristor, if the delay angle was 0, it would switch on there and I would go up on that path there. But now I don't switch on. I wait 30 degrees, so I'm going to go down here and only then am I going to switch over. Did I answer you? Okay. Now, I want to find out, what is this current? This current I2 of mine, is it positive, 0, or negative? So I go and I find out that it is minus 2,823 amps at the point where I would have switched over to the next line voltage. Now if it's negative, then it means it has gone through 0 previously. And the moment that it goes through 0, the thyristor that was conducting switches off. And then we're going to have this situation. The thyristor S1 switches off. It means there is no energy to close the commutating diode. And then what will we have over the motor? The back EMF E. So we must find out, where does this current go through 0? And you can either use Newton-Raphson or you can use iterations. And I used iterations and I found it to be 4,7 milliseconds. So after 4,7 milliseconds, there is, after 4,7 milliseconds, from this point on there, that current goes through 0. What remains is 0,3 milliseconds of having a E voltage over the motor. And that's why I have this area now there, because both switches are open. Here, one thyristor is closed. Here, another thyristor is closed. And all I now have to do to determine V mean is integrate those wave shapes there and divide by the period. Okay, now I'm first going to write down what I have in the book. I said if you want to calculate V mean is equal to 1 over t of the integral between 0 and t of Vt dt. So in this case, that's also the same as Vdc, and it's equal to 1 over 2 pi over 3. Now, do you agree that t is 2 pi over 3? You see, I've indicated t there, but if I go that 0,3 that we have there, if I subtract that on both sides here, then I can just as well have gone from that point there to this point here. Do you agree? So that is 1, 2, 3, 4. 4 times pi over 6. Because each one of these is pi over 6. 4 times that is 2 pi over 3. So I think I must ask this one in your first test. Eh? That was just a joke. Eh? Right, then I've got a section that I said is from pi over 2 over 2 pi over 3 V line max sin omega t d omega t. Now those limits, where do we find them on this graph? We find those limits there's pi over 2 and there's 2 pi over 3. So we are talking about that section there. Starting at pi over 2 and going up to 2 pi over 3. Correct? Are you happy with that one? Or do you think you're going to look at it later? Then the next section, I say, starts off at pi over 3 and it carries on to pi over 3 plus theta of V line max sin omega t d omega t. So let's go and look at that section there. That section there is I start off here at pi over 3. And then it carries on to this point here, and I've named that section there theta. That is the time until it stops. The current stops flowing, which is 4,7 milliseconds. How many radiances are that? How do I convert? It's 4,7 milliseconds divided by 10 milliseconds multiplied by pi, which gives me 0,47 pi rad. And then the last one is, I said, plus E, and the limits are 0 and pi minus theta. Sorry. How do you like that one? Oh, what did I write? Pi minus theta. Do you agree with that, or do you think it's a misprint? Do you agree, or is it a typo error? It's pi over 2 minus theta. Are you taking a chance? Did you work it out? Okay. Where did you work it out? Yeah. Okay, so if we take from there to there, yeah, so it's a misprint, guys. It must be pi over 2 minus theta. And then our answer, if we've done the integration sum and put in the limits correctly, then we get that V mean is equal to 282,13 volts. To get to the mean current, I take the mean voltage, I divide by R, and the answer is 2,955 amp. If I want the torque, it is I mean times the torque constant, and that is equal to, what was the torque constant? 2. So it's 2,955 times 2, and that gives me 5,917 Newton meter. Yes, sir.
Why are you saying the limits for the back EMF is from 0? Why are you starting at 0?
Okay, I know. Oh, okay. Let's just look at this graph here. Let me just see. Why did I go and put 0? Okay, the reason for that is I went and I said, well, if I take pi over 2 and I subtract theta from it, then what? Remember, pi over 2 is 5 milliseconds. Theta was 4,7 milliseconds. So what am I left with? 0,3 milliseconds. And that 0,3 milliseconds is the difference that I want if I subtract the upper limit from the lower limit. So if you really wanted it to put it in there, then you should have said it is from see, it makes it very complicated, because then you must say, okay, I'm going to start off from pi over 3 plus theta, okay, is my lower limit. So I'm going to start off as I say it's pi over 3 plus theta. Now where do I start? That's my problem here. And then when I go up to the end limit here, that end limit was at 1, 2, 3. So that's pi over 2. So what will I have when I go and subtract this? You see, what I did is I just went and looked at that E, and I decided it doesn't matter where it is in relation to the others, in relation with the sine waves. All I want to know is for how long does it start. And then I said, if I went and I said t is equal to, I start off there, that is a lower limit, and here is a lower limit, and there is an upper limit. All I'm interested in is that I will get for the sine wave, I will get the lower limit and I'll get the upper limit. But for the E value, all I'm concerned about is how long is that E present. And that's why I went and I said, okay, make my lower limit 0. And my upper limit, I make sure that the difference between the two will just be the time that that E is there. So it was really I crooked a bit. Because otherwise it becomes too complex. Okay, so that concludes the 3-phase DC motor drive. There's only one example, and it's that one. I can vary